39 meters, 37 meters, and 35 meters in each of 3 consecutive seconds along a straight railway track. Show that this is consistent with motion under constant deceleration. How much further will the train travel before it comes to rest? All right, draw yourself a picture. Right? It's safe to say the train is not rest. Do you see the word rest even once there? No. That means the train is moving with its initial speed u. Okay? It travels for a second. So this is at t equals 1 from A to B. And it travels 39 meters. Cool with that? Then it travels from B to C, but B to C is slightly shorter. Once again, takes a second, 3 consecutive seconds. And the distance this time is 37. Everybody cool with that? And then finally C to D, which is how far? 35. Once again, t equals 1. Now, after a while, we're going to slow down, and we'll call this point E. E is the point at which your velocity equals 0. Is that okay? It's not drawn to scale. I'd imagine D to E is going to be a much bigger gap than, let's say, C to D. Does that make sense? Now, what was the trick with bet home on Wednesday? In every single one of these type of questions, what did I always do? Yes, sir. I started from A. Exactly, and you have to do that. Do you know why you have to do that? Yes. Yeah, it gives a constant variable. So if this is A to B, U equals U. If this is A to C, U equals U. And finally, if this is A to D, U equals U. You're keeping a common starting velocity, and it means you have one less variable to deal with. Okay, they're all the same. Everybody cool with that? That's the first trick. The V's you're not going to be bothered with, because the V's are different for every section. So what I mean by a V value, for those of you that are relatively new, is that when I start off moving, I'm slowing down. By the time I get to B, I have a different final velocity. That'd be my V value in this section here. When I get to point C, I'm going slower again. That'd be my V value for here. But we don't. The V value is different in every data set, so we don't want to work with that. Okay, that'd be awkward. Now we're going to treat the deceleration the same. So I usually do color code each one, just so we know which data set I'm working with. Okay. Now let's start off with the red set, which is A to B. What's our A value? Just call it A, will we? Our S value? 39, and our T value? 1. All right. What's our A value for AC? Still A. Our S value? 39 plus 37? 76. Our T value? 2 seconds, because first second from A to B, second from B to C, T equals 2. Okay, what about the third data set? A is still A. S this time? Add on another 35 on top of that. 111, thank you very much. Our T value? 3. Everybody cool with that so far? All right. You have a choice of your equations. You can go for phi equals u plus at. Phi squared equals u squared plus 2as. Or s equals ut plus a half at squared. Which one should we choose and why? What choice are we going to use? All right. Has to be s equals ut plus half at squared. Remember we said we're not using the v's because the v's are different in every section. That pretty much rules out 2 equations, doesn't it? Because both of them have v in it. So we're only left with 1 equation left. All right, in we go. Let's start off with the red section. So what do we get here? 39 equals u times 1 plus a half a times 1 squared. u plus a half a equals 39. I don't like fractions, so I'm going to multiply both sides by 2. 78 equals 2u plus 1a. That's from the red data set. The blue and the purple are similar choices. There's no real difference. I'll just go blue for no reason at all. I could go purple as well. It doesn't matter. So we'll go with the blue set. So same trick again. What do we have this time? 76 equals u times 2 plus a half a times 2 squared. And now what you get? 76 equals 2u plus 4 half or 2a. We can half it this time, and what do we get? 38 equals u plus a. All right, I'm going to do the green equation, take away the yellow equation, okay? So you're going to multiply the yellow one by -1. So it's going to be 2u, so I keep black here, 2u plus 1a equals 78, and then it's going to be minus u minus a equals minus 38, and then we're going to have a u value of 40. Okay? But we know that u plus a is 38, so what does that mean for the a value? A is -2. Okay. Do you know what was odd here? They gave us too much information. Do we really need the third set? No. Well, we do for the next question, don't we? Yes. Uh, 39, 37, and 35. You probably could. That's because they're very nice to say that t equals 1 every time. What you do was t equals 3 or something like that. It'd be more difficult. Yeah. I'd show the technique though. You get what I'm saying? Now, here's what we got to do now. We have to find out how long it takes to get to rest, don't we? How much further it will take before it gets to rest. Why don't we do it this way? U equals, what do we say, 40? If you're at rest, what happens? Velocity 0. A we know is -2. Do we know the S value? Do we know the T value? No. Which one are we looking for, S or T? S. Let's find S. What selection are you going to choose? Yeah, v squared equals u squared plus 2as. And what do we get here then? 0 squared equals 40 squared plus 2 times -2 times s minus 1600 equals 4s. S equals 400. Now, I don't get full marks for that. Can I explain why? Read the language of the question. How much further? I've already traveled 111 and I stop after 400. So how much further did I go? 400 take away 111. What do we get there? Yeah, who got 289? Two even. All right, good job. A few of you's got it. All right. It's possible. Now, a train starting from P accelerates uniformly for 10 seconds, travels at uniform speed for 32, and decelerates for 6 to rest at Q. So we're going to do a velocity time graph. We're going to change this to 1,000 meters. When the maximum speed reached and the distance travelled during each part of the journey. So let's begin. Draw an XY axis, velocity, time. I'll put down time because I usually end up using t somewhere along the route here. Now, we get our acceleration period takes 10 seconds, which means that it takes 10 seconds to get this velocity. We travel, don't know how long to make that. Actually, ideally the constant velocity stage is a lot longer than the acceleration and deceleration stage, so I'll make it a bit more realistic. The deceleration more aggressive or less aggressive than the acceleration? More powerful, isn't it? How do I know that? Only takes 6 seconds to get back down again. So I had to make this a bit steeper. Is that okay? You have 3 sections. You have triangle A, rectangle B, and triangle C. The area of A plus the area of B plus the area of C has to equal 1,000. The total distance travelled is the area under the graph. Okay? Now, next thing. We have our, do we need the ratio trick? That's 32. B is 32 seconds. Everybody caught that? What's A? 10. And C? 6. All right, so we have our total time. This is relatively easy, actually. Yeah, this is an easy one. Half base times height. Half 10 times what? V. For part B, the rectangle is length times height, which is 32V. In part C, it's a half base times height, so a half, what's this, 6 times? V equals 1,000. Now what do we get here? 5V, 32V plus 3V. 40V equals 1,000. Phi equals 25. Have I answered the question? What do I have to do next? I have to find out what A is. I have to find out what B is. And finally, I have to find out what C is. Okay? Everybody knows C is 3V. B is 32V. And A is 5V. We already used it earlier, didn't we? So I'm just going to multiply 5 by 25 gives me 125. So that's the distance covered in A, that's 125. Next one is 32 times 25, which is anybody? Somebody got it for me? Huh? 800, thank you. The last one should be 75, all going well. And then 3 times 25, 75. And there's your breakdown of your acceleration, deceleration, and constant velocity. Well, good. Okay. A Japanese monorail train leaves that place where it stopped and accelerated at 2 meters per second to a maximum speed and immediately decelerates. What's the significance of seeing immediately? Yes, sir. Yeah, it's a triangle graph, up and back down again. Which one's more extreme, the acceleration or the deceleration? So it'll look something like this, a longer acceleration period and then a real short deceleration. Everybody cool with that? Distance covered in A would be bigger than the distance covered in B. Everybody cool with that? Now, some tricks for you. What's tan x represent? For argument's sake, I'll call this T1 and V. What's tan x? V over T1. And tan x is actually the acceleration. Just a trick. What would tan y be? Tan y would be V over T2, which will be the deceleration. If I got an answer of 2, it actually means the deceleration is -2. Is that right? Because you know it's on side down. All right. Now, we got some information about the time. What information can I use about the time? Would everybody agree that T1 plus T2 equals 90 seconds? Everybody good with that? So for argument's sake, if I was to call this T, what would the other one have to be? 90 take away T. Because when you add T1 and T2 together, the answer has to be 90. Everybody good with that? All right. We also know the ratios between them as well. All right. We know there might be a way of doing this as well. I remember my ratio trick. What's the ratio trick? The ratio is 7 to, how do I know the ratio is 7 to 2? The time taken from here to here is in a ratio with the time taken here to here of 7 is to 2. 7 times the smaller time equals 2 times the larger time. Would that make sense? I could set up an equation for that now, couldn't I? 7 times the smaller time equals 2 times the larger time. I wonder will this yield any information for us? Oh, it will. 630 equals 9t, t equals, there we go. We know T1 is 70 and T2 is 20. Believe it or not, I didn't even have to go through all that. I was almost trying to be too smart. Like, the way I would have done it the other day would have been like this. I would have said that's 2t and that's 7t, wouldn't I? What's 2t plus 7t? And 9t equals 90. T equals 10. That makes that section 20 and that section 70. It's weird. Sometimes you try different things on different questions, but we could just do the trick I've done every other time, couldn't we? It's the same deal. Same net result, okay? No matter what way you look at it. So now we're in business. We have extra information here. Where does the extra information come in? The acceleration and the deceleration. So phi over 70, which is the acceleration, phi divided by 70 equals what? 7. That's interesting. What's the phi value then? Huh? So I just want to double check this. Phi over 70 is 7. Oh, sorry, the acceleration is 2, thank God. Yeah. I was thinking that's the fastest train I've ever seen in my life. It's just like something's up here. There's something wrong. So phi over 70 equals 2 because the acceleration is 2. So what's the phi value then? Meters per second. All right. Are we capable of getting the area of the full triangle now? Can we get it all in one go? I need base times height, don't I? We know the height is 140 and we know the base is 90. So I have 140 times 90. And what do you get? 2,000? 6,300. Whoa. 6,300. Anybody got that out? One good, 2 guys, 3 guys. All right. All good? Once again, passes 4 signals, each 24 meters apart. It's moving as it goes through them. Everybody cool with that? So, A, B, C, D. They're all 24 meters apart. Is that cool? There's a 4 of them, is it? 4 of them would indicate 3 sections, okay? The first one is T equals 2. Second one, T equals 1. Third one is what we're looking for. How long does it take to go from the third to the fourth? We're assuming we're already moving, aren't we? So we have AB, we have AC, and we have A to D. Once again, we're not doing. We're always starting at the start, going to the end. Okay. What's the T value by the time you reach D? We don't know, do we? Do we know the S value? 70. Do we know the S value for AC? Do you know the T value? Yes, 3. And we know the U value to be U. Then this one here. U is U, phi we don't know, A is A, S is 24, and T equals 2. Which formula are we going to use? It's the one we used earlier. The only one that hasn't got a V in it. S equals UT plus a half AT squared. So, using the black data set, it's 24 equals U times 2 plus a half A times 2 squared. 24 equals 2U plus 2. A. 12 equals U plus A. All right. Now red ones. 48 equals U times 3 plus a half A times 3 squared. 3U plus 9 over 2A equals 48. Inclined to double this. So 96 equals 6U plus 9A. Nah, just leave it like that, I suppose. Now we have the yellow one and the blue one. I'm going to multiply the yellow one by -6 and take it away. So the yellow one multiplied by -6 and do it that way. So I'm going to get -6U minus 6A equals -72. Blue one stays the same. And then we should get 3A equals 24 and A equals 8. If A equals 8, what does U equal? U equals 4. Everybody cool with that? Now, data set AD. We have U, V, A, S, T. S is 72. A is 8. U is 4. Phi we don't care about. And T. If I find the total time, what can I do then? Take away 3 seconds, can't I? Because when you're starting at C, you're already 3 seconds in. And when you finish at D, you want the time in between C and D. Well, if I find the distance from A to D, or sorry, the time from A to D, I can figure out that way. Now, you have a choice here. Okay, pause here. Okay, you have 2 choices, guys. Your first choice will be phi squared equals U squared plus 2AS. You end up finding the V value. Then after that, you use phi equals U plus AT. and then you can find the t value. That's a two-step process. Doesn't involve a quadratic r minus b formula. The second direct route is to use s equals ut plus a half at squared, and this will involve a quadratic equation. So let's do it this way. 72 equals 4t plus a half 8 times t squared. 72 equals 4t, what's that, plus 4t squared? Alright, this ain't looking so bad, okay? Let's move it all to one side. 4t squared plus 4t, take away 72. Divide by 4. T squared plus 1t. What's 72 divided by 4? It's 18, is it? Now, let's be honest, we're always using the minus b formula here because it's going to be a decimal answer, wasn't it? So use the minus b formula. Your a value is 1, your b value is 1, your minus b formula is minus 1, and your c value is minus 18. So do we need to be concerned with the positive and the negative, or just the positive? Why is it just the positive? It's an answer for time. Time cannot be negative, so just do the positive answer and your goal, okay? Minus 1, b squared is 1 squared, minus 4 times ac, which is 1 times minus 18, all over 2 times a. Put that into the calculator, let me know what you got. What's the t value in this answer, guys? Has to be bigger than 3, doesn't it? Why does it have to be bigger than 3? Yeah, so you have to be going longer than 3 seconds. If you don't go longer than 3 seconds, you've made a mistake. Anybody beat me to it, yeah? What? 4.27? 2. Yeah, have a look. Is he accelerating or decelerating? He's accelerating, so if anything, he should be going faster. 3.77. So I knew 4.28 was wrong purely because it took him 1 second to go from B to C. Going from C to D should be shorter because it's also 24 meters. So I knew there was something up, okay? So T equals 3.77. This means the time in the last interval was 0.77. Is that okay with you guys? All right. Question 7 then. Cyclists A and B leave the same spot from rest and travel in opposite directions. You can be A, you can be B. B going this way, A going this way. Happy days. Now, what's the UVAS for A? And we know what UVAS for A is? 0. A is? T is just T, isn't it? Oh, we have acceleration, 0.5. Yep. Oh, T equals 10. Thank you, Neil. Read the question, Mr. Kenny. That'd be a good call. Now, for B, 0, 1, anybody else? Yeah. Don't get too caught up in the fact that B is going the opposite direction. Don't worry about that. You don't need to think too much about minuses or stuff like that, okay? Also, you need to know is that you just need to add S1 onto S2. Does that make sense? S1 plus S2 is the answer. How far did S1 go? If I traveled 50 meters to the right and B traveled 40 meters to the left, how far apart are we? We're 90, aren't we? So you don't have to worry about negatives and positives here, okay? So just do S equals ut plus a half at squared. So S equals 0 times 10 plus a half 0.5 times 10 squared. Somebody's going to give me that answer in a second. And the next one is S equals 0 times 10 again, but this time it's a half 1 times 10 squared. Okay, what's the answer for the first one? 20. And the answer for the other one? 50. Gives me a total of 75 meters. Method now, okay guys, here's the alternative method. See the way I have to do two different formulas to get the answer? Okay, essentially something like this. We're going to do it combined. So imagine for argument's sake, one person was traveling 20 meters per second to the right and the other person was traveling 10 meters per second to the left. What's that the same as? Somebody staying stationary and the other person going away at 30 meters per second. Do you get what I'm saying? It's the same effect. They're going to be separating out 30 meters every second. Does that make sense? So this is what's called relative velocity. There's a full chapter on it, but we're not going to touch it just yet. But what I can do is I can combine my two data sets like this. U is 0 because there's no there's nothing there, right? But the acceleration can actually be turned into 1.5. Why is it getting turned into 1.5? If one of them's going right at 0.5 and the other one's going left at 1, we can just turn it into 1.5, and the t value is still 10. And instead you could have just done like this: 0 times 10 plus a half 1 times, 1.5 times 10 squared, which will get you your 75 meters directly. Is that what you're telling me? All right, don't worry. Now, let's try this again for the next one. We have two competing methods now, don't we? Yeah? So, if I use method 1, it will be S1 plus S2 equals 108. Everybody cool with that? Their combined distance when they separate is 108. What's the difference between this equation and the last one I did? Do I know the t value this time? So if I just go back here, and this time I'm just going to lob in the t's. A t here, a t here, a t squared here, and a t squared here. So S1 will be what, guys? S1 will be just a half t squared. What will S2 be? T squared equals 108. Had we done this directly, you can see that it's going to add to give you 1.5, isn't it? So 1.5 t squared equals, yes? Oh, sorry, my bad. Thank you. Sorry, guys, I'm wrong. The half's my fault. It's a half of 0.5 is 0.25 t squared, and then a half of 1 is 0.5 t squared. Good spot. 0.75 t squared equals 108. Somebody divide 108 by 0.75. You get 144. And then the t value is 12. And had you done the direct methods, you would have got the same thing. You would have got S equals ut, which is 0 times t, plus a half 1.5 t squared, and you'd still get your 0.75 that way. Okay, all good? Right, move on. 19. How far did I give this for homework again? Oh God. Right, let's get that far. So, cyclist traveling at a constant speed of 12 meters per second passes a point P. 5 seconds later, so I would have covered this on Wednesday's class in a similar question. Does anybody remember what I did? So let's call it A and B again. Yes, sir, what did I do? Yeah, it will be 60 meters behind. Before we get to that even, there's another trick to be had. So constant velocity means 12, 12, A equals 0. Who's traveling longer, the cyclist or the car? Huh? How much longer is he there for? So this one can be t plus 5 and the other one can be t. What's another way of doing that? You could say that this one's t and this one's t minus 5. Do you get what I'm saying? If you choose two competing systems, they still come out as the same answer in the end. So for example is one way I'll get a t answer of 10, but the other one I'll get a t answer of 5. But remember, you have to add on 5 to make it 10. So either way, what will happen is your answers will come out the same way. Okay? If you don't understand anything else, the answers will come out the same way. Okay? Now, what about the other thing? What about the car? What's its story? Starting from rest, acceleration, 1. The greatest distance the cyclist leads the car. Yes, sir. Yeah. Cyclist gets how far ahead to begin with? 60 meters. Where do we get 60 meters from? 5 multiplied by? Huh? 12. 60 meter head start. After that happens, who's gaining the lead for the first while? The car's not moving really, is it? So the cyclist continues to stretch its lead while the car only moves a small amount. Makes sense? At what point does the car start to catch on the cyclists? Or at what point does the cyclist no longer extend its lead? When v equals 12 meters per second. Both the car and the cyclist are going 12 meters per second. This means that the cyclist is no longer extending its lead on the car. Anything after that, the car is going faster than the cyclist and will therefore close in. Everybody cool with that? All right. Yeah. There? Yeah, getting there. All right, come on. Now, okay. All that we need to do now is the v's equal each other. So v equals u plus at. We can find the t value, can't we? Using a data set B. So use data set B, and what should we use? V equals u plus at. 12 equals 0 plus 1 times t, and therefore t will equal 12 seconds. Everybody cool with that? Have we answered the question yet, though? What do I have to do here? $12 here. Yeah. 70 in here. We don't even really need the see the 17. That includes the 60. So you don't even need to worry about the 60 now. Because that's the 5 seconds extra, isn't it? So it will include the 60 meters that you're talking about. So don't worry about that. All right, let's find out what S1 and S2 are. So what's S1? 12 times 17 plus a half, 0 times 17 squared. And what you get? 12 times 17? What? Somebody just multiply it for me. That'd be awesome. Huh? Okay. What about S2? Bigger or smaller? Should it be bigger or smaller, lads? Why should it be smaller? because it only just reached 12. The cyclist has been traveling faster all this time. Put it in and what you get? 72. What's the greatest lead then? One of them travels 204 meters, the other one travels 72 meters. What's the greatest lead? Huh? 132 meters. Yeah, good. All right. Okie dokie. All right. At a certain moment in the Tour de France, Alberto is 22 meters behind Gustav. Alberto is cycling at 12 and accelerating at 1. Gustav, who has just fixed the puncher, starts from rest and accelerates at acceleration 2 meters per second. All right, this is an interesting one. Alberto, Gustav. Okay. Gustav has a U value of 0, but an acceleration of 2. Alberto has a U value of 12 and an acceleration of 1. What is the significance of the slower person having the bigger acceleration? Anybody else? Sorry. What's the significance of the slower person having the bigger acceleration? Okay, go on, tell me. Gustav is going to get overtaken, but because of his superior acceleration, he's eventually going to go faster than Alberto and catch him back up again. That's going to happen no matter what. Is that okay? So, let's try this out. All right, what's the gap? The gap is 22. Okay. The T starts at the same time, doesn't it? So we'll do Alberto as U vast red. Alberto. And then 12, 1, no idea, T is T. All right, Gustav, U is going to be 0, A is going to be 2, B is God knows what, S is God knows what, and T is T. Oh. After how long will Alberto catch up with Gustav? Okay. What can we say there? What's the formula? How much extra distance does Alberto have to travel compared to Gustav? 22 extra meters. So S1, which is Alberto's distance, take away what Gustav does, has to be 22, because Alberto has to do 22 extra meters to catch Gustav. Everybody happy with the initial formula? Okay, how do we do that then? Anybody? Put in the S formula. So UT plus a half AT squared. Okay, let's do this. 12 times T plus a half 1 times T squared equals what, guys? Oh, sorry, nothing at the moment. Take away who's then? That's Alberto. What do I need to take away now? I'll take away Gustav's, which is going to be 0 times plus a half 2 times, and that will equal 22. Everybody cool with that? So what happens next then? 12t plus 0.5 t squared, take away just 1 t squared, yeah, equals 22, minus 0.5 t squared plus 12t minus 22 equals 0, multiply both sides by minus 2, t squared minus 24t plus 44, is that right? Ah, perfect. T equal T minus 2 and T minus T equals 2 and T equals 22. Interesting. That means they're 22 meters apart twice. Does that make sense? So it means that Gustav will be, who's in the lead at the moment? Gustav's in the lead at the moment, isn't he? Gustav will be in the lead by 22 meters twice. He'll eventually overtake Alberto again and build up a 22-meter lead. Does that make sense? That's why there's two answers. That's why there's T equals 2 and T equals 22. Anybody want to read cheeky way of doing this one? All right, show you another method. The other method could be like this. You combine both data sets together, like this. Let's pretend that Gustav never moves. So the idea here is relative velocity. Gustav never moves. How much is Alberto catching up with him at the beginning? 12. Whose acceleration is more powerful, Alberto's or Gustav's? So Alberto's actually losing -1 on acceleration compared to Gustav. Everybody got that? What's our S value? He has to make up 22 meters on the stationary Gustav. Gustav's not allowed to move. Okay? And look what happens when I do it this way. We're looking for the T value, aren't we? S equals UT plus a half AT squared. S equals 22 equals 12T minus a half 1 times T squared. And guess what? I'm going to end up with exactly the same equation. 0.5 T squared when I move it over minus 12T. Huh? Oh, it is. Sorry, and that's +1. Same trick, yeah? And then that's plus 22. And that's actually the same equation I had 3 minutes ago, isn't it? So you can do it that way, and it's quite quick as well. All right, let's go back again. After how long more will Gustav overtake Alberto again? What does that mean? S1 equals S2. When you overtake somebody, the distance you travel is the same. Does that make sense? So this means the total distance traveled by Alberto. Wait. So how long will Alberto catch up with Gustav? We already did that, didn't we? Okay. Just to try and explain this one more time. He came level with Gustav. Alberto caught Gustav after 2 seconds. Okay? But then 22 seconds later, 22 seconds in total are level with each other again. Because this formula is the distance covered by Alberto, take away the distance covered by Gustav is 22. Anytime that's 22, because Gustav started 22 meters ahead of Alberto, anytime that's equal, it means they're level at that point in time. So it'll be 20 seconds later. Is that all right? Now guys,